Hi everyone, welcome back to our channel. So today we are back with a new video for our system design playlist series. So where we gonna discuss about very important concept of scalability. You're gonna love this topic because you might have felt this pain throughout your technical career in some part of it as well. So this video is gonna be one of our last videos before we say bye to 2025. So we have thought about this playlist and thought about this video as well effectively, how we can brainstorm around this and give you this video or this topic in a more presentable way. I hope you would love it. And if you haven't subscribed us before, so go ahead and subscribe the channel and do if you do like our content, do share our videos as well. So without further ado, let's get started. So in this diagram, I have shown a basic representation of how a user interacts with your application and how your application looks at the backend, how it works behind the scenes to deliver the same experience to the user in the front end. There are different processes, there are different architecture components that make this entire picture happen in the real time. Now let's say there is an actor. You can name this actor as a user by his name. User goes to the browser, types in the website name that you have, then it lands onto the website. Now the website has a backend system. Backend system can be made of different components. Some of the components we have named in the big box that we have, which is gateway, which is app servers, which is database. We haven't named some of them. Let's put them here. Let's say our CDNs. Let's say our routing service. Let's say our load balancers or gateways. Let's say our caching systems. So I'm just naming all these components which I haven't depicted in this big box in one box itself, so that you understand that all these components are in your architecture. Let's assume that way. You have gateways, you have app servers, you have cluster of systems, you have databases, you have CDNs, routing services, load balancers, and caching systems. Now, we are talking specifically about scalability. Now, what scalability is actually, first of all, we need to understand that scalability is, let's say, you are able, you are there are 100 users on your application on day one, and you have, let's say, one app server to handle that, or let's say you have definitive amount of compute to handle that, one app server, one database cluster, and one gateway, and so on. Now, imagine your traffic increases 10 times. Okay, let's say today there is 100 users, tomorrow there are going to be 1000 users on the daily basis. Today, if your service or if your server is able to handle all those hundreds users effectively and complete their requests on time, tomorrow when you do 10 times of your traffic, which is 1000 users, then all those 1000 use to serve all those 1000 users, you should do 10 times of your compute capacity as well. Okay, now if you are having 1000 users, you need to do increase your compute also 10 times. If you have one app server, you need to make it 10 app servers. Now after doing it, if you are able to serve your 1000 users, then it means you are able to scale linearly with your compute or with your infrastructure and in proportional to your traffic. Whereas if 1000 users which are coming to your website are not getting fulfilled, let's say out of 1000 only 900 or let's say 800 requests are getting fulfilled even after adding 10 app servers, then it means your system is not a good scalable system. This is a metric that you need to understand and effectively monitor, that is your system scalable enough or not. This is the definition of a scalability. Now we need to understand about different scalability patterns. Now, to understand the scalability patterns, we need to understand where and when and how to scale different architecture components. Now let's talk about gateways. You can scale gateways, like you can add more gateways in different regions, availability zones. That is one part of it. Then you have app servers. Now let's comes to the app servers. Now The normal chronology in the mind is you can scale your app servers by adding the new, I would say, horizontal new containers. As much traffic is increasing, you will keep on adding your app servers in your cluster to handle those scaling traffic that is coming in. That is one of the notion that we have today in the containerized world. Now you can scale the app server horizontally, like you can add multiple app servers here. Let's say I keep on copying these app servers in my cluster. So then as the load is increasing, I'll have my container management service which will keep on spinning up the app servers copies as well to handle that increasing load. This is one of the normal or genuine concept that everybody has in mind. Now another concept is to vertically scale it. So sorry, horizontally we have already talked about. Vertically scale it. What do you mean by vertically scaling is, let's say if this app server has a memory of or a RAM of some XYZ number, then you can scale up that number of memory or a RAM or a storage system itself in the same box rather than adding new containers as and when the traffic is increasing. That is called vertical scaling. So I'll keep on listing down all those concepts also here for you. So one of the concept is vertical scaling, which we are talking right now. The earlier which we talked about is horizontal scaling. I am adding this in the list on when we should apply this and in which order we should apply this. So vertical scaling is the first thing that we can apply to scale immediately our incoming traffic without much of an hassle. Horizontal scaling is the second concept that we can apply to scale our traffic. Let's say you are scaling the vertical or you are scaling the vertical part of it, but there is a threshold ceiling limit beyond which you can't scale vertically. So you have to move to horizontal concept. So which means you can add more app servers, you can add more database. I would say you can. So we have talked about the app servers till now, but we'll go to now the database concepts as well. Now, let's say we talked about the app servers and the other components to scale. Now, let's talk about databases. How to scale databases. Now, the problem might be in your database itself. If you are not able to handle the increased requests, the problem might be in database. Problem might not be in your app servers. So, your app servers, if you have two app servers running or 10 app servers running, they might be able to handle all those requests, but your database is not. That's when you have to look at the metrics and find out where you should scale. That's where I talked about. We'll find out where to scale and when to scale and how to scale. So where to scale, you have to find out. You need to scale app servers or the database. App servers, if you want to scale, these are the two prominent patterns everybody knows. Now we'll go to the database part. Let's say we find out database is the bottleneck, not the app servers. Then we'll see how many database clusters or how many database engines we have. Not engines, I would say, but database containers we have. Let's say we have one as of now, one database which is catering to read and write. Now, if database is a problem, we have to scale it. Then let's think of master and follower concept or master and lead kind of concept. So, where one node will be for writing and rest of the nodes, let's say you will add two or three nodes for reading. Okay, now this is again a kind of horizontal scaling concept where you can keep on adding your nodes to scale your database requests load that is coming in. This is the first step. Whenever you have to apply scaling concept in your infrastructure, this is how you can do. Now when you go deep dive into it, let's say you have done all this and still you have to scale more. Now let's say initially we were 100 users, now we are 10,000. Now we go to 1 lakh or let's say 1 million or so. So now we have to scale through other patterns. These are the patterns that will help you to scale under certain limit. But after that, if you keep on scaling with this kind of pattern, you may hit high cost in your architecture itself, that's when you have to think of something else. And management also will get tricky if you keep on scaling with this kind of concept in the longer run. Now, let's say you have to scale now to the next level. What are the next scaling patterns? You can add caching if you don't have. So, the more requests which are going to the database, so rather than adding more read nodes, you can add caching layer. This is one of the simplest concept which most of the application would have. Second one, or the last one, or I would say after caching, would be sharding. That is sharding the database. Now that depends what kind of sharding you want to do. You want to break down tables into different shards, like let's say you have different nodes in your database. Now if you have hundreds of tables, you put 20 tables in one node, 20 tables in one node, and so on. Or else you can break down the columns also, like you put these many rows in one table, these many rows of each table in one node, these many rows in another node, and so on. So these are all the sharding concepts of scalability which will help you to scale to the next level. This is the scaling concept that we have. Now all these are scaling, or I would say scalability patterns. Now apart from this, there would be some other scaling patterns also, like asynchronous processing. Because if your system, let's say if your app server is taking too much of time to process or do a math or do a calculation, and even if you add more containers or scale your VM box to with high memory, and still it is not able to take that load, so you might think of doing the asynchronous processing as well, where you can use queues to scale. Let's say you have to let's say when the income tax interest rate filings reports comes in, so then the traffic is quite huge, everybody wants to generate the reports and all. So many users will hit your systems at that time. Now at that time your app servers will be under high load to compute the reports and show you the or email you the reports and all that. So then it will take a lot of time to do the maths in that app servers. So that's where the asynchronous processing for those kind of activities would help you to scale your system better. That's where the asynchronous processing also is quite beneficial in scaling patterns as well. Now all these things that we have talked about, these are from the application database, or let's say compute level. Now if there are a lot of people coming on your website which is a static website, and your website is taking too much time of to load as well, and at the same time you are not able to reduce it, that's where CDNs comes into play. To use CDNs to scale your static website or website traffic itself, to deliver them the content in quite low latency and quick time as well. So these are some of the scalability patterns that I wanted to talk about. This topic came into mind because I felt that some of the associates are still not clear with the scalability patterns and how to use them effectively in different use cases. So I hope this video will help you and guide you better in terms of choosing the scalability patterns also going forward. So if you do like our content, do subscribe to the channel and like and share our video to your friends and families also. Thank you. Have a nice day and Happy New Year.